instructor for this recitation. My name is Shahera, Jannah. And if you want to know a little bit about me, is that I started teaching from 2019. So I'm relatively new compared to other instructors, other experienced instructors. I did my bachelor on applied math, my master's on pure math from City College. And currently I'm doing my PhD at Columbia University on math education. I taught at City College, Hunter College, Barrett College, Marty College. Currently I'm teaching only at Barrett and Hunter. And I taught the lecture for people. I think at least for 2 years. And also I completed it takes you less years to coming out of thinking because it just wants paper. It takes you more years to coming down the code. So how are the lectures? You have only 2 lectures, right? On your phone? You didn't have to lecture? Oh, cool. So how are the class lecture? How did you like it? Did you like it or you got scared? Being scared of the first day of class is normal. So if you got scared, no problem. It means you're normal. Okay, so recitation is like tutoring session. I'm going to help you, you're going to help your peers. Okay, that's how it works. So in every class, you do one recitation, front and back, and they're also available on Lumen. Once you're done in class, you're going to come in at the end of the class. But if you don't know how to do it, or if you didn't complete them in class, no problem. You can turn them in the next class. Okay? And the recitation is 10% of the grade. Initially, I was thinking of including recitation plus attendance 10%, but then I changed my mind. I was like, okay, only recitation is fine. Attendance is up to you. If you're not here, you're gonna miss me. Okay? Because my plan is to help you as much as possible. And trust me, in pre-calculus, you do need extra help. Okay? So if you're missing the recitation, you're missing all the extra help. But good news, I tend to record my lectures, so even if you're absent, you can actually watch them later. And then you can review them before your exam. I usually do a good review before the exam, and that review is based on exam questions. Okay. Any question before we start?
So you're not taking attendance for the recitation. That means the 10% that you talked about in the recitation is going to be based on.
Only on the paper. Any other question? Yeah. Okay, so today's recitation is just a review from your algebra class. So you did algebra class probably last semester or before that. Probably forgot many of them. So this is just to refresh your memory about all the algebra things you'll learn in your algebra classes. So we'll start with some basic rules. Exponent rules. Let's see how much you remember from your algebra. Okay, let's, we have a base and Wow. We have same base twice, and you're multiplying the base. How do you combine them? Is it too small? I'll try to write bigger now. So how do you combine your exponents? You add them. So keep the base once, but you add all the exponents. It doesn't matter how many exponents you have, you just add them. Second rule, what if you have division? We subtract. And actually we have two rules. We subtract the denominator from the numerator if the numerator is bigger than denominator power. Or we do 1 over x to the denominator minus the numerator power if the denominator has the larger power. You can apply one rule, but then if denominator is bigger, you subtract from the numerator, you get a negative number, negative power. And the negative power has another rule. So either you can do it in 2 steps, or you can simply remember if denominator is bigger, the answer must be the denominator. Okay, now how about if we have two powers together? Only one base, but multiple power. What do? We multiply them. So keep the base, but we multiply. It doesn't matter how many numbers you have, we just multiply them. Okay, now multiple base. Let's say you have more elements in the base, but you have only one exponent. Now what? We distribute. You could have infinitely many numbers in your base. Well, it doesn't matter what you have, your power always goes to everything. So a to the n, it's not my writing for some reason. The page is not writing well. See, it's writing half and it's leaving half incomplete. So this is n, this is b. Okay, okay. How about if we divide the base and we have numerator? Sorry, we have power exponent. What do you do now? Come on, guys. You really don't remember? We distribute again. Whenever you have a single power, always distribute. So you put them on the top and on the bottom, a to the n and b to the n. So one base more power means you multiply the base. If you multiply the bases, you add the powers. But if you have only one base but multiple power, you multiply the base, multiply the powers. If you have more elements in the base, it doesn't matter whether you're multiplying or dividing. If you have a single power, you distribute. Question? It depends on what you're doing. Once you're doing some math where the distribution is needed, that means you're going to distribute the power. But once you're doing some math in the final step, you get this, you don't have to distribute. Okay, what else we have? Negative power. Let's say you have a to the negative 5. 1 over a to the positive 5. So your exponent, if it's negative, we hate that because we hate anything negative in our life. So when you have negative exponent, we cannot leave it. We have to make the negative into positive. All you have to do is make it as a fraction. But what if you have a division with a negative power, any power? Now what happens? How can you make this negative power into a positive power? Just make a guess. Multiply the positive power. Two ways you can remember. The details method is the exponent rule says it doesn't matter what exponent you have. If you have more than one element in the base, distribute them. So we have a to the negative n divided by b to the negative n. But then again, we cannot have negative power. So we know we can make this positive if we bring it on the bottom. Same thing, if you want to bring the denominator positive, just move it on the top. They'll turn into positive. So b to the n, if you put it on the top, becomes positive n. A to the n, if you write it on the bottom, it becomes positive n. So this is the details method. However, there is a shortcut. All you have to do is flip your fraction, the negative power turns into a positive power. So b over a turns into a positive negative n into a positive n. And then if it's necessary, you do one more step, you distribute the n, you get b to the n over a to the n. Okay, so two ways you can do. One is do details, other one is just flip your fraction, the negative times the positive power. Radical. If we have square root of x, how can you rewrite this without the radical but using exponent? X to the 1/2 power. So every radical is actually a power, but it's a fraction power. How about cube root of x? X to the 1/3. So it doesn't matter what is the radical, what type of radical you have, it's always 1 over that radical. So in general, rule is nth to the x, it would be x to the what? 1 over n. That n could be any number, 2, 3, 4, 5, 6, 7, 8, 9 million, it doesn't matter. But what if you already have an exponent in your base? So nth root of, let's say, x to the m. Now x already has a power, and also it has a radical. X to the m over n. Good. The power is special. It has more power. It is exponent. So we keep our exponent alone, x to the m, and we know any radical turn into a fraction. So we move the radical on the denominator. So following this rule, what do you have for square root of, let's say, x to the 5? X to the what? X to the 5 over? What is the radical? 2. When you have no number in the radical, you still actually have a number. It's called square root because we have invisible 2 there. The 2 is always invisible, okay? Only for 2, we don't write anything. Except for 2, for every other radical, we write them down. It's cube root, 4th root, 6th root. But for square root, we all are so smart that you already assume that there's a 2 in there. Okay, so that's it. I think these are all the rules. Any question on the rules? No? Now let's do some example. Oops. From our worksheet. Which one you want me to do, A or B? A? Okay. So A has something inside and then outside the negative power. The favorite way, the method I like about other methods is first simplify it inside and then apply the radical. So not radical, apply the power. Okay. So since I love this, I'm going to show you this method. I have negative 2 power, ignore. Unless you don't have anything in there. Just observe what you have inside the parentheses. And in the parentheses, we have A with negative power on the top, B with negative power on the bottom. We don't want that. We want A to have positive power, B also to have positive power. Question 1. How can you make A to the negative 1 into A to the positive 1? What rule we learned? To convert negative into positive? Bring it to the bottom. So we are going to bring A on the denominator and it will become a positive. And how can you convert B to the negative 5 from the bottom into B to the positive 5? What do you have to do? Bring it to the top. So B goes on the top, A comes down on the bottom. So let's rewrite them. We have, no, blue is good. A is on the bottom, so we are going to write A on the bottom. A with a positive power. Now, A with the 3 power already is on the bottom. Then we have B square on the top. We like it. It doesn't have any negative. So we keep our B square on the top. C also doesn't have any problem. So we keep our C on the top. On the denominator, we have a cube. We keep it. The B to the 5, we don't want that. So we put it on the top. It becomes B to the positive 5. And C square is a positive number. So we leave our C square alone. So every negative, we switch their position, they turn into positive. Now we are still ignoring our negative 2 power, but we just have to bring it down. We can ignore, but just to bring it down. And now let's simplify our insight. What can you do here? Remember the rule says, if you multiply the same base, you actually add the powers. So in the next step, we are going to keep our B and we are going to combine 3 and 5. We are going to get 7. How about the denominator? What is happening on the denominator? What do we get? Same story. We are multiplying A. That means we are going to add the powers. We get 4. But what is happening to C? In division, what do you do? Subtract. So where are you going to put our C? On the numerator or on the denominator? Which position we are going to keep? Denominator. Why? See, I said whatever has the larger number, we keep that and we subtract the other one. So our C square is big, so we keep our C square on the bottom and then we subtract the 1 from the top. So 2 minus 1 gives us 1. So this is C on the bottom and then 2 minus 1. We still have our negative 2 power. We still ignore in this step. But in the next step, we're not going to ignore them. In the last step, what did you get? A to the fourth power with what? Well, you get lost. So we have a to the 1 from the numerator and denominator only has a 2, right? So what you're doing with them, are you multiplying them or are you dividing them? What sign you have between them? So I can do the 4. For C, we have C on the top, C is on the bottom. So it's a division, right? In division, what do you do? Keep the larger one, separate the smaller one. So larger one is the denominator. So you keep the C on the denominator and you separate the 1 from the numerator. So the denominator is C to the 2 minus 1 power. That's into 1 power. And now I don't want my negative 2 anymore. I want to make it positive 2. What do you do? Flip. We're going to multiply the next step. But for now, we are going to flip them so the negative will disappear. So a to the 4c on the top and b to the 7 on the bottom. And now the 2, again, it's not my doing, okay? The PDF is not letting me write on it. So denominator goes in the numerator comes down on the denominator, and negative disappear from the power negative 2. Okay, so we like it because there's no negative anymore. Now what do you do? When you have more elements in the base, but only 1 power, what do you do? We distribute the power to every element in the base. So our base has A, B, C. We need to distribute the 2 power for everyone, A, B, C. So we get a to the 4 with an extra 2. C is a single, it gets the power 2. B to the 7 is on the bottom, it gets the extra 2. So we distribute the 2 to everything. And now, what rules do we have for more than 1 power together? What happens to the 4 to the square? What rule we have? Multiply them. So a to the 8, c square, and b to the how much? 14. And now we are finally done. We cannot combine them anymore. We cannot simplify them anymore. So, any question from anyone on any step? Was any step unclear, confusing? No? So you'll do B by yourself. Let me skip 2 for now and go to 3. Huh? B is alone in the denominator. Question 2. Which one you need help? Which one you think is harder, A or B? Probably B. Guess what? B is the easy one. Let me show you A. So you'll see why B is the easy one. In my morning class, I'm teaching 2 recitation. In the previous one, I asked the same question. There was a D. But D is one right now. Why? Because we have the same radical. When you have same radical, it's very easy. It becomes kind of complicated when you have a different radical. A has two radicals, two types of radicals. The first one is a fifth radical. The second one is a square radical. Okay. So when you have two different radicals, you cannot combine them directly. First, you have to convert them into exponents, and then you can combine them. So how you're going to rewrite this? What rule we know? Perfect. 4/5. Which rule? This rule. Oh, sorry. This one. When you have a radical and power at the same time, power must be on the top. Radical goes on the bottom in a fraction. Okay, so we rewrote that. And how about this one? X to the 3/2. So 3 is visible, we can see that, but square root square is invisible. It just becomes visible in a fraction form. Okay, now we can combine, but using which rule? How are you going to combine them? Same base multiplying means add the powers. So x to the 4/5 plus 3/2. And then you have two ways of doing it. Since you allowed to use calculator, or use a ring. If you do want to use a ring, we cannot combine them until we have the same denominator. So what is the least common denominator between 5 and 2? 10. So we want to have 10 on both denominators. So we need to multiply the 5 by what number to turn it into 10? 2. But we cannot just multiply the bottom. We also have to multiply the top. So multiply top and bottom by 2, the first fraction. And the second fraction, you have to multiply by what? 5. If you have the same denominator, only then we are allowed to combine the numerator. So first numerator is this, then we have this side, and then this is our second numerator. So what do we get on the first numerator? Plus 15. And how much is 8 and 15? 23. Oh, it's 10. So it's x to the 23/10. You can keep this, you don't have to simplify any longer. You can simplify more, but you don't have to. In fact, in pre-calculus, we don't need this. These are just basic algebra rules. Okay, so B is easy because you don't have to follow this rule. For B, you can combine two radicals into one radical. I'm not going to do it. I'm just going to give you a simpler direction. Since we have the same radical, we keep the radical once and combine both bases. First base is x to the 7, second base is x squared. So simplify the inside first and then rewrite it to exponentials using the exponentials. That's why it's easier. Any questions so far? Okay. For B, oops. I'm not going to do it, but I'm going to give you the direction. We just learned that we cannot add or subtract until we have the same denominator. But here we don't have the same denominator, right? So we need to have same denominators. But the problem is both of them are polynomials. And if you're going to multiply one polynomial by another polynomial, yes, you can do that, but why should I make it harder? Because then you have to factor in. So when you have a polynomial on the denominator, it first there should be factor, if it's possible. Now, can you factor this? Do you remember how to factor trinomials? You do? Two numbers multiply to 20. When you combine, it becomes 9. What are the two numbers? 5 times 4 gives us 20. And if we add them, you get 9. So plus 5 plus 9, a variable is x. How about the next one? Two numbers multiply to 12, combine to 7. 4 and 3. How about their signs? Both of them have to be positive. Plus 4 plus 3. You actually do need to remember your factoring. You're going to use it a lot in future things. Okay, so anybody needs help with factoring? No? So two numbers multiply to constant, combine to the middle term. Once you decide the two numbers, the middle sign always goes to the bigger factor. So our 4 is a bigger one, so 4 has to be plus because our middle term is plus. And then to get 7, our 3 also has to be plus. Okay, so we have x plus 5 and x plus 4. Can you guess what is the LCD for both denominators? X plus 4 is a common factor. So they both have x plus 4. Yeah, remember, LCD means we want to have the same thing on both denominators. So if you compare the two denominators, they both have x plus 4, so we are working with x plus 4. Now the problem is we have x plus 5 here, but we have x plus 3 here. They are not same, they're different. If they are different, we want both of them under both denominators. So on both denominators. So we have x plus 5, we want x plus 3 here also. We have x plus 3 here, we want x plus 5 there also. Then we can have the same thing on both denominator. So the extra thing we need here is x plus 3 because we have it here. Same thing here, the extra thing we need is x plus 5 because we have it there. So now if you look at both denominators, we have the exact same thing. X plus 3, 4, and 5. All three of them. So LCD is x plus 4, x plus 3, x plus 5. But like I said, math is fair. So you cannot just randomly put something on the denominator. Whatever you put on the denominator, you must put the same thing on the numerator. So we want x plus 3 here because we put that on the denominator. And we want x plus 5 here because we put that on the numerator. So on the denominator. So when you have the same denominator, we don't want to waste our energy by writing it twice. So we write it only once and we combine all the numerator, just like before. Our first numerator, no. our first numerator times the second numerator. Okay, it doesn't let me do anything. In our next class, I'm going to use something different. So we have x plus 3 and x plus 5. So we get x plus 3 minus 4x plus 5. The only thing you need to be careful about is that whenever you subtract something, the sign change into a minus. We don't have to worry about the sign if you're adding two things. But when you subtract something, you always have to change the sign for the second term you're subtracting. So you're going to do the rest. Combine them, distribute them, subtract them, and then refactor and cancel. Okay. Any questions so far? No. Okay, let me go to the second page real quick and show you one. For question 4, A is harder than B. So let me do A and we'll do B. So here our goal is to simplify the radical. When you simplify the radical, based on the number and variable, we apply two different rules. Okay. So for number, we need to divide the number by any perfect square number. For variable, we observe the power, the exponent, and see can you divide the exponent by the radical. If you can, then how many times you can do that. So this 2x, it has nothing on its power, so it's single. So you leave the 2x alone. We don't have to do anything with them. Now 32x cubed, we are going to split 32 into two pieces. Square root of a perfect square number and square root of not a perfect square number. For radical, you can do the same thing. Square root of x to the something divisible by the radical and something not divisible by the radical. Square root means what number we have? 2. So we want something here that is divisible by 2. Okay. But let's start with 32. If you split 32, one of them is perfect square number, what two numbers you can have? 9 times 4 is 36. But you're close. 8 and 4 perfect, but then you can split 8 more. 4 times 4 times 2, 32. 16 and 2. So, yes, you can use 4, 4, 2, but if you combine 4 and 4, you get a bigger one, 16. So you split 32 into 16 and 2, because 16 is a perfect square number. What perfect square number we get from 16? So from here we get 4. This is extra, we carry down. And this, we have nothing to do. We just bring it down. And now we want something, let me erase this. We want to split that 3 into 2 pieces. One number should be divisible by 2, other is not divisible by 2. So how are you going to split 3 into 2 pieces? X to the what number? 3, you have only 3, right? Are you going to split? 2 and 1, right? 2 is divisible by 2, 1 is not divisible by 2. So it's 3 turns into 2 and 1. 2 and 1 is 3, but we are splitting them because square root of square, we can simplify them. The square root, square part cancel out. We left with a single x without any radical. And this one, we have nothing to do. We just bring it down. Now, what do we have outside of the radical? If you combine all of them together, what do you get? We have a number 2, number 4. We have an x with another x. Combining them, what do you get? Huh? Louder? Louder. For x, we get x squared. And how about the number? 2 and 4. 8. So we have 2, 4, and extra x. 2 and 4 gives us 8. X and x squared gives us x squared. And we have the same radical twice. Why wasting our energy writing twice? We write only once and combine the inside. What do you get inside the radical? 2x. So this is what we get from simplifying only the first term. Now we still have to simplify the second one. So plus, we are going to split the 18 into 2 pieces, and we are going to split the x into 2 pieces. One piece will be divisible by 2, one piece will not be divisible by 2. So 18, which two numbers give us 18? One of them is perfect square. 9 and 2. Square root of 9 gives us, and 2 we have no idea, so keep it. Now how are you going to divide 5 into 2 pieces? One is divisible by 2, one is not divisible by 2. But here you can simplify, right? 4 and 1. In fact, whenever you simplify square roots, all you have to do is split your power into 2. One is less than the power, and one is with the power. So when you have x to the 5, it will become x to the 4 and x to the 1. If we have x to the, let's say, 55, it doesn't matter. It's same thing. X to the 54 and x to the 1. Because when you divide any number by 2, there is a 1 remainder. That is not by 2. 1. So it's x to the 4 and x to the 1. Now from here, we are dividing 4 by 2 because it's square root. So what do you get here? 2, right? Because this is x to the 4 over 2, which turns into 2. And this one, we have no idea, so we'll leave it alone. So here, the extra thing outside of the radical is 3 and x squared. And inside the radical, it's 2x, same thing. You can stop here, or you can do more. Oops. Since we have the same radical, you can pull it out as a common factor. So you get square root of 2x, and then you have 8x squared plus 3x squared. Can you combine?
If there's one just all the way to the left.
But you're adding them. When we add, we cannot cancel it to combine the coefficients. Can you combine 8x squared plus 3x squared? How much again? So luckily we can do more. So it turns into 11x squared with the radical term 2x. But for B, it will not be combinable. We cannot combine them, so just leave them alone. So B is same thing. Just follow the steps, simplify them. At the end, you combine them. Any question on this? Was any step unclear to anyone? You guys are just too shy, right? I know many steps should be unclear to you. Because you already forgot many things from algebra. It's normal. So even if you're shy too, there's no problem. I understand today is the first day. It's normal to be shy. But eventually, please don't be shy anymore. Ask me any question whenever you don't understand. And today I went slowly. That's why our time is over. Probably you did not finish the paper. If you're not, no problem. Give me in the next class. Huh? If you're done, you turn them in. If you're not done, you have it. You keep it for now. Bring it in the next class. But it's still 2 more minutes. Should I introduce you the next one? The next question? Rationalizing. The last one is easy because they only give you the rule. You just have to follow the rule for 6. For 5, rationalize. Whenever you rationalize something, it means we don't want to see the radical on that position. It is rationalize the denominator. It means we don't want to see the radical on the denominator. If it says rationalize the numerator, it means we want to see the radical on the numerator. So when you rationalize with 2 things, we use, there is a term. Do you remember what term we use for that? Start with C-O-N. Conjugate. Do you remember what is conjugate? Does it ring any bell? It's the same exact thing, just the sign is different. So we have 1 and radical 3. So a conjugate will have 1 and radical 3. But we are given plus sign, our conjugate will have a minus sign. If you are given minus sign, the conjugate will be the plus sign. So conjugate means the exact same 2 things, 2 terms, just their middle sign is different. So if you multiply top and bottom by the conjugate of the denominator gets rid of the radical sign. So numerator is, we need to do distribution. So 6 times 1 gives us 6. 6 times negative radical 3 is 6. Negative 6 radical 3. Then 3 times 1 gives us positive radical 3. And 3 times 3 with the negative sign gives us negative radical 3 squared. Because they are multiplying the same thing twice. Radical 3 times radical 3. So radical 3 squared. Since we are doing the numerator, so let's keep simplifying the numerator first. And then I'm going to go to the denominator. These two are like terms because they have the same radical. So if you combine negative 6 radical 3, positive 1 radical 3, how many radicals do you get? Negative 5 radical 3. When you combine radicals, we add or subtract their coefficients. So this has coefficients negative 6, and this has coefficients invisible 1. When you combine, we get negative 5. And then the radical and power cancel out, we get minus 3. Now the only like terms we have here is 6 minus 3. So we get 3 minus 5 radical 3. This is the numerator top. For denominator, you can do the same thing, or you can use the special formula. The special formula says if we have the same thing, if you have two conjugates, their product is first one square minus the second term square. This is shortcut. It's called difference of perfect squares. So we get 1 minus 3, that gives us negative 2. This is the bottom. If you put top and bottom together, our top is 3 minus 5 radical 3. Our bottom is negative 2. That's it. Put them together, you get the answer. You can write the same answer many different ways, but if you want to keep it, no problem. Any question? Okay, so if you're done, please turn them in. If you're not done, no problem, do it at home. And bring it to the
Thank you. I would say- Because I wrote in pants on it.
Yeah.
For every time that you have, I had to be
So goodbye, everyone. See you again next week.